In this video, let's focus on stoichiometry calculation. And we're going to dive into different parts of calculation involving stoichiometry calculation. So this is going to be a complete video. So now let's check the first question. You say butane react oxygen to form carbon dioxide and water. Do you get that? So this is a complete equation between what butane and what oxygen to form CO2 and what water. So before you can solve this kind of question, first of all, you must write a balanced chemical equations like this between what the two reactants to form what the product. If you don't have a balanced chemical equation, there's no way you can what solve that problem. Do you get that? So this one here is for this one here. So let's look at what the first one here. So if 3.4 mole of butane react with excess oxygen gas, how many gram of CO2 will form? It means that look at something here. It means that you are going to convert 3.4 moles of what? Of C4H10 to gram of what? CO2. Do you get that? So what it means is that first, we are going to move forward from mole of C4H10 to what? Mole of what? CO2 before you can get what? Gram of what? CO2. Now, this is our calculation here. You have to look for the molar mass of this compound. Do you get the molar mass of C4? Then you have to look for molar mass of what? CO2. So, what is the molar mass of CO2? Molar mass of CO2 is equal to what? 44 gram per what? Per mole. Do you get that? It means that for every 1 mole of what? CO2, I have what? 44 gram of what? CO2. Do you get that? The next one to look at is the molar mass. Molar mass of what? C4H10. If you do the calculation, so here if you calculate what the molar mass of C4H10, here I what? 58 gram per what? Per mole. Do you get that? It means that for every 1 mole of what? C4H10, I have what? 58 gram of what? C4H10. Do you get that? So we are using this one here. Now remember, we are converting what? 3.4 mole of C4H10 to a gram of what? CO2. So first of all, we move from mass of what? C4H10 to what? Mole of what? CO2 before I can get what? Gram of what? CO2. Do you get that? Then it must move in what? In this direction. Remember, our mole of butane was given to us, right? So it's going to be 3.4 mole of what? C4H10 over what? 1 times. Remember, I told you that we are moving forward for mole of C4H10 to what? Mole of what? CO2. The next you want to use here is what? Balance equation between what? Balance equation between C4H10 and what? CO2. If you check it very well, if you check the balance equation, 2 mole of C4H10 equals to what? 8 mole of what? CO2. Do you get that? It means that 2 moles of what? C4H10 is equals to what? Equals to what? 8 moles of what? CO2. Do you see that? So what will happen here? Now this will be at the direction will go to the top. You get so here you have 2 moles of what? C4H10. Do you see that? They have 8 moles of what? CO2. So I want to write this place out. I'm going to write this place out. Now remember, we are moving forward. Mole of C4H10 to what? Mole of O2, right? If you check it there, this guy, you cancel out this guy. Then what am I going to use there? I'm not going to use what? This one here. 1 mole of CO2 equals to what? 44 gram of what? CO2. Do you get that? Now, here the mole go to down 1 mole of what? CO2. You have 44 gram of what? CO2. Because that this guy and this guy want to cancel that. Do you see that? Now we ask, are we not using this one here? We are not using this one here because there's no point of using this one. We are not starting from gram. Do you get that? We are not starting from 1. We are starting from mole. Do you get that? That is why we did not use what? This one. But in the other question, I believe you are going to use it. So when you cancel that, what will happen here? You have 3.4 times 8 times 44 gram of what? CO2 over what? Over 2. So you have to punch your calculator and what? Get your answer. 598.4 gram. This is the what? Answer. Do you get that? This is the what? Answer. So we are going to look at what? Question 2 now. Look at what question 2. So it says how many gram of oxygen? Do you get that? How many gram of oxygen gas will completely react with 3.8 mole of what? Butane. That is, I have what? I'm converting what? 3.8 moles of what? C for H10 to what? 2 gram of what? Uh, to what? Gram of what? O2. Do you see that? So then I'm going to move from mole of C for H10 to what? Gram of what? C to what? Gram of what? O2. It's the same thing we have done. You get? So first we want to do so what? Get the molar mass here. But since I'm starting from mole, the molar mass of this one is not really important. What I'm going to use here is what? Mole of this one equals to mole of this one here. So the first relationship I'm going to use here is uh, 2 mole of what? C for H10 is equals to what? 13 moles of what? CO2. How do I get that? From the balance equation. Do you get that? The next I want to do now is what? The molar mass of what? The atomic mass, sorry, the molar mass of what? O2. So molar mass of what? O2 is equals to what? Going to be 16 times 2. Right? 16 times 2 going to be what? 32 gram per mole. Now what does this mean? It means that for every 1 mole of what? O2, I have what? 32 gram of what? O2. You have to what? Take note of this other one here. So these are the two relationships I'm going to make use of. Do you get that? Now, remember, I'm using what? 3.8 mole of what? Butane. So it's going to be 3.8 moles of what? C4H10 over what? 1 times. Now, remember, before we get to what? To gram, I must convert what? Mole of C4H10 to what? To mole of what? O2. Using what? This balanced relationship here. Do you get that? Now, because this my mole is already top, this will go to the down. Why some mole of O2 go to the top? So it's going to be 30 moles of what? CO2. Sorry, O2. Here we have 2 moles of what? Of C4H10. Do you see that? Because that times, yeah, I'm now use this one here, the what? The molar mass, right? So we cancel that this, we cancel out this one here. Now here I have 13, so here I have what? 13 mole of O2 here. Mole of O2 go to the down because here we have 1 mole of O2 equals to 32 grams of what? O2. So let it be 32 gram of what? O2. Here we have 1 mole of what? O2. Because that this, we cancel out this guy here. What happened here? What left here have 3.8 times 13 times 32 gram over what? 2. What do you want to do? So push your calculator and what? Get your answer. So let's use our calculator to get our answer here. 790.4 gram of what? O2. This is the what? Answer. Do you get that? So the next thing is what? Is C. If we pause the video and see if you can what? Solve for C. Do you have to pause the video and see if you can solve for C? Now let's look at what C. If 25 grams of what? C4H10 react with excess oxygen, how many moles of water will be formed? Do you get that? So that is, we are converting what? 25 gram of what? C4H10 to what? 2 mole of what? C4 to what? Mole of what? To mole of H2O. Do you get that? So I have to know the relationship between this guy and this guy here. You understand? For my balanced relationship here, 2 moles equals to what? 10 moles, right? So I'm going to write that. So here we have 2 moles of what? C4H10 is equal to what? 10 moles of what? H2O. Do you get that? Remember, I'm starting from the gram of what? C4H10. That is, I need to know the molar mass of C4H10. Do you get that? So molar mass of what? C4H10 is equals to what? Remember, we have calculated before to be what? Uh, 48 gram per what? Per mole, right? We're going to be what? For every 1 mole of what? C C4H10 are what? 58 gram of what? C4H10. You have to what? Take note of this guy here. Yeah. So this stuff you are actually what? Going to make use of. You get now because we are not converted to what? To mass of water. So there's no point of you calculating molar mass of water. Do you get that? So there's no point. So if you check it very well, remember what are we starting with? I started what? 25 gram of what? C4H10 over 1 times. Now I need to know what gram of what? C4H10, right? So what will happen here? I will use this one here. So here I have 58 gram of what? C4H10. Do you see that? 58 gram of what? C4H10. Here I have what? 1 mole of what? C4H10. So that this will cancel out this one here. Remember, our final destination is what? Is mole, right? So for me now, I'm going to use what? The balance relationship. I want to use this balance relationship here. So instead that we are only using this one here, we have used one here, right? Then sorry, yes. So we are using one here. So here we have this relationship here times here we have 2 mole of what? C4H10 equals to 10 mole of what? H2O. So yeah, because mole of what? C4H10 is already at top. This will go to the down. So here I have 2 moles of what? 2 mole of what? C4H10. Here I have what? 10 moles of what? H2O. So that this we cancel out this guy here. So what I'm left with is 25 times what? 10 what? Moles of what? H2O over 58 times what? 2. What I'm going to do here, so we use my calculator to punch my answer. You get to get what my answer. So here I have 2.155 mole of what? H2. So this is the what? Answer. So you can see that in C we are converting what? Gram of C4H10 to what? Mole. Do you get that? So that's why we only need these two relationships here. This one is getting from the balance relationship here, right? Between what? C4 and what? H2. Then because I'm starting from gram, I have to look for the molar mass of C4H10 because what I relate 1 mole of C4H10 to what? Equals what? 58 gram of C4H10. Do you get that? So when I did this dimension analysis, I must arrange them in such a way that unit must cancel out units. Do you get that? So that this one cancel this one. This will cancel as well. What I'm left is this one here. So when I do the calculation, do what I want to get. So pause the video and try D for me and see if you can solve D. So let's look at what the D part. If 38 grams of water are produced in reaction, how many moles of CO2 were produced? Now, it means that we are converting what? 38 grams of what? H2O, right? To what? Mole. To mole of what? CO2. Can you see that? So in the sense that we need to what? Look for the molar mass of this guy. You get that? You need to look for the molar mass of what? Water because it's one that was started what? Gram. So molar mass of what? H2O is equal to what? 18 gram per mole. If you do the calculation very well, right? 18 gram per mole, right? 18 gram per mole. It means that for every 1 mole of what? H2O. For every 1 mole of H2O, I have what? 18 gram of what? H2O. Do you see that? Now, because Because they say she will convert what to mole of CO2. I want to look at the balance, the what, the relation between the two of them. You get that? So 10 mole, 10 mole of what, H2O is equals to what, 8 moles of what, CO2. This is that. So these are the two relationship I'm using in the what, calculation. Do you get that? So once I know two of them, it's very easy. Remember, I'm starting what with this one here. So it's going to be 38 gram of what, H2O over 1 times. I'm now going to use what, the mass here, this one here, right? So yeah, my gram is already at the top. So this one will go to the down. So it's going to be 18 gram of what, H2O. Yeah, what, 1 mole of what, H2O. Do you see that? So that these and these will go at, can you see that? Times, what happen? I'm not going to use this one here. My mole of water is already at the top, so this one will go to the down. So it's going to be 8 moles of what, CO2. Yeah, what, 10 moles of what, H2O. So this and this what to go at. So what I'm left with is what, 38 times what, 8 moles of what, of CO2 over 18 times what, 10. So what will be the answer? So here I have 1.6 1.69 mole of what, CO2. This is the what, answer. So this is a typical way of solving questions. Although there are other methods, there are other what, method, but this is the method I really want you to what, master. If you check my first video I've done, I did what, the two method. So many people say that they love this method than the other method. That's why I'm using this one here. But if you want to checkmate the other method, then you can check out the last video I've done on stoichiometry calculation. You see it here, display here. And if you don't know how to balance reaction using the algebraic method, you get that? Because as a chemistry student, you must know how to balance chemical equation. Do you understand? So if you don't know how to balance chemical equation using the algebraic method, then you want to check out this video display on the board. So we have the first video that they explain so here. Then you have to check out the algebraic method of balancing chemical what, equation. If this video is helpful and follow through what I've done in this video, because I've solved 4 questions. So these 4 questions should be able to what, explain the concept for you, and now you can what, tackle every other what, question. If this video is helpful, please type in the comment section that this video is helpful and you follow, you love the content, so that I can what, produce more of this kind of content for you. If you are not subscribed to the channel, please hit that subscribe button and turn on the notification bell, because we produce content on a consistent what, basis. Thanks for watching. So go check out this video. I'll see you there.